Great, thank you. Thank you for coming to our October meetup for Docker. Appreciate everybody showing up tonight. We've got another one planned for next month. I'm still lining up the speakers for that, but hopefully we'll get that going. And I guess tonight we have a couple of different talks, so I'll keep it short so we can get things rolling. We've got Ilan from Datadog talking about monitoring, and I think he actually might have a different talk, but I'm not sure. I guess we'll find out. And then Ahmet talking about the state of affairs in Microsoft more on the client side, and then Taylor talking about Docker on the server side at Microsoft. And then we've got Christian from Sumologic talking about monitoring and logging in Docker. So just out of curiosity, how many people over here have been, how many people over here use Docker in production? Okay, so a couple. And who here has not heard of Docker, Docker 101, doesn't know anything about what this whole Docker thing is all about? All right, cool. So all the speakers, you guys know what your target audience is there. All right, great. So as always, I'd like to thank Disney for this location. It's a really cool place. Dev9 for all the pizza and food and everything. You folks for coming, and the speakers for coming to talk. So I guess with that, I'm going to hand it off to Ilan, who is the Directory of Technical Community at Datadog. Start off with the first talk.
Good evening. Thanks everybody for coming out and taking time on your Tuesday evening here. Is anybody actually in town for Chef Summit this week as well? No? One. Cool. Just get set up here. While I'm getting going, how many of you guys are anybody a Datadog user in the audience or familiar with Datadog and what we do? Okay, I see a couple hands there. Cool. Well, thanks for being customers, and for those of you that aren't, we won't hold it against you, but I'd be happy to hand you some stickers afterwards and talk about how awesome Datadog is. Cool. So as was said, the presentation topic changed slightly. The one surprising fact about Docker I will tell you tonight is that I am not going to speak about the other 8 surprising facts about Docker. Unfortunately, due to some snafus that did not happen tonight. But yeah, so again, my name's Ilan. I'm with the Datadog team. I lead the community and evangelism teams. Just a quick note about. Sorry, crashing. Unfortunately, we do not monitor. Cool. So that's a little bit of a variance of picture, so we'll keep on going. But about me here at Datadog. So I've been a long-time Datadog user. I was a user of Datadog for a number of years. Just prior to that, I was at companies like Ilan and Edmunds.com building automation and monitoring tooling. If you go back, probably, I don't want to count how many years, I was actually an employee out of the Digs off the Disney Internet, Walt Disney Internet Group office out of North Hollywood, doing security and security monitoring. So monitoring's been something I've been doing for a while. No, there we go. Cool. Something I've been doing for a while, and so always happy to chat with you guys, whether that be here or elsewhere, about monitoring, about Docker, or anything alike. So again, quick 30-second pitch about Datadog. I promised I wouldn't do a sales pitch up here for too long. But basically, we're a hosted monitoring solution. We will monitor most modern applications, although lots of older things as well. We tend to excel at things like dynamic infrastructure, containers, so whether that be Docker, Amazon's EC2 container service, Mesos, etc. Basically things where your infrastructure is coming and going, although we can monitor anything. Basically, it's time series storage of your metrics and events. We're not going to do slicing. We're not going to do search on your logs. That's the Sumologic guys in the back do a fantastic job on that. We're going to hear about them a little bit later tonight. As a long-time Sumo user as well, so I encourage you guys to take a look at that. And then we do some exciting things that other monitoring systems don't tend to do. Things like anomaly detection, some more advanced alerting functionality than you might see in some of your legacy monitoring systems. Since we're going to talk about monitoring tonight, I thought we'd do a quick crash course in good monitoring. It's something we've got a ton about it online. There's a link there in the slides, and I'm sure it'll be up on the Meetup page later. But we like to think of monitoring data falling into 3 categories. The first is work metrics. If you think about your application or your environment as a small factory, maybe you're outputting cars or widgets or whatever it might be, that's the way we like to break up our metrics. We like to see it as work, that being the output of your factory, resources, that's the raw materials going into producing that thing that you're selling, and events being sort of decisions that you've made along the way that help provide context around it. So in the case of a web application, maybe running Nginx or Apache, throughput as an example of a work metric would be the number of pages you're serving per second. Your success rate at producing that widget, again, the page delivery would be something like 200 responses, errors would be 500 responses. These are just quick examples. I like to use them because everybody knows how a web server works when I come to these meetups, but if I start to dive into the intricacies of Docker containers like we'll do a little bit later, or about your Java your J2E container, you may not know those metrics, so these are the place to go. Resources are things like CPU, memory, network, I/O, things like that. These are the things that the building blocks that go into making the work product. And then finally, events are things like your deployments. So generally, if you make a decision, whether it be a commit, a deployment, you decide to restart the application. Maybe you're again, you're using Docker with fantastic things like Kubernetes and Mesos, and your scheduler decided you need 100 more workers, and it spun them up, and then it realized you don't need those anymore, spun them on down. Those are events. So how do you want to use that data? Generally, you want a page on work metrics. At the end of the day, you probably don't care what your CPU utilization looks like. It doesn't, and nor do your customers. They're not going to pay you less because your CPU usage is high, or pay you more because your CPU usage is low. They care about how many times did that API return what they were looking for. If you're rendering video for movies here at Disney, maybe they care about the number of frames per second you're able to get out the door. Probably dating myself on rendering metrics from render farms, but in any case, that is the work output. That's what you want to page on. If you see that dip, if you see that increase past where you're looking for, those are the things you want to be alerted on. You want to wake up in the middle of the night, or maybe you have a knock, they'll get paged, they'll take a look at it. So what about those other types of metrics that we talked about, the events and resources? What you want to do is be able to link those into your work metrics and find those relationships. And so what you're going to do here is, as you dive in, you're going to start to look at, you got paged about a work metric. Again, your number of pages per second has gone down, or maybe a number of errors per second has gone up. You're going to want to take a look at why. Is CPU usage high? Maybe that's the cause. Is CPU usage low? Maybe that's the cause. And you can use those to inform your decisions about how to respond to that incident. Similarly, events. Maybe those errors are now being caused because you chose to do a deployment. So you had to put out some bad code. I'm sure that never happens at any of your shops. You also have fantastic QA processes. But those are events. And so what's going to happen is you're going to take those two sets of data and use them to inform your decision about how to get your work output back to where it needs to be. And so then you're just going to keep doing that until you recurse. So maybe you're going to keep recursing until you find the answer to your root cause. So maybe maybe it's not. Maybe your web tier output is low, but it's because somewhere in your app tier, your DB tier, there are issues. And so you're just going to keep recursing down in each of these boxes again. So it says this is the web tier. Here's your app tier, here's your DB tier. As you kind of work down, you realize, oh wait, the problem is maybe I'm missing an index on a database, maybe one of my database nodes died, whatever it might be. But you're going to keep working down until you find that root cause. So again, that's monitoring 101 in a total of, I think, 3 minutes. If you want more on that, we've got some fantastic series of blog posts at that link there. I'm happy to come back another time and do a full-on hour on how to monitor properly. But anyways, we're here to talk about containers, so let's dive into that. You containerized your app. It's here in this container, it's awesome, and it's everything you dreamed of, right? You're using, again, we talked about Kubernetes, Mesos, ECS, whatever it might be, your work's getting scheduled. You're not getting woken up in the middle of the night about resource shortages, because what happens when you need more resources? The scheduler just does it for you. And as we start to dive into that, do we really trust that? It's great that we have these containers, it's great that we have these schedulers, but how do we know that our application is really working the way that we expected it to? How are we going to dive into health? Well, we're all looking around the room. I think we've all been in IT or engineering for a while. If there's a metric around it, we monitor it. If it's going to move, we monitor it. If it doesn't move and we think it's going to make a break for it and go somewhere else, we still monitor it, right? Even if that line is supposed to be straight. The goal is always know everything about your app. Monitoring is cheap. It's cheap to collect when you have it, and it's fairly expensive to get when you don't. So getting that data for an event that happened in the past is impossible, right? So But in this land of containers and dynamic infrastructure, right, we have to think about complexity and what do we do with all that data. The complexity is going to increase with the number of things we want to measure. That's pretty straightforward, right? How do we make sense of all that data that's coming in? And the second is with the velocity of change. How often is our infrastructure being replaced? How many times a day are we doing deployments? How many times a day are we scaling up, down, what have you? So we all know in dynamic infrastructure land, whether that be, again, auto scaling in one of our favorite cloud vendors or with containers with schedulers, it's going to happen all the time. So again, looking at number of things, the second would be number of things to measure. So if we're looking at hosts, let's say I'm just back to the napkin math. So let's say for every VM we maybe have 10 or more metrics depending on the vendor that we're working with for our monitoring system or the vendor that we're working with for our app. We probably have 100 metrics on the operating system, everything that, all that fancy stuff under proc that you may or may not know what it does, but it's interesting and important. The number of containers, now we take that 100 metrics and we multiply that by the number of containers running on our host. And we've got about 100 about 100 metrics times the number of containers and 110 for that, that supervising system. That's cool. Okay. I wonder how many metrics that really turns out to be. So how do we get that out of the containers, right? There's a lot of ways to get metrics out of Docker, whether it's with a Docker stats command or we're going to look at the remote API. This is just an example of a CLI to pull that from the stats agent. And we start to look at that, and I can't even fit the number of metrics coming out of Docker on this slide. That goes down somewhere down around here, right? So that's a lot of data, and we're going to start to figure out what do we do with all that? How do we figure out what's important? Where do we store all that? So again, coming back to our math, we're saying about we've been seeing about 5 containers on average per host. That metric's a little bit dated. It's towards the end of last year, beginning of this year, but hasn't changed too much unless you start to think about things like CI systems or build processes, render farms, things where you're probably lasting for even shorter periods than that. We have to do n times post to manage that. We're going to look at how we're going to provision that, configure that, orchestrate that, and then again monitor that, which is the key piece here. So just doing some math. If we had 100 VMs or 100 instances in EC2, it's about 500 containers, again, assuming 5 containers a host. If we're doing 160 metrics per host, now we're doing about 610 metrics per host. That's a lot of things to kind of keep in your head as you're looking at it. Now we go out to 100 virtual machines, and that's 6,100 metrics. Maybe that's a lot, maybe not. Then we, again, velocity, looking at that. How often are you tearing your containers down per day? The reason you use containers is because it's easy to tear them up and shut them down. They take seconds to do. So things that used to take us hours are now taking us minutes, or even seconds. So I promised a little bit about the exciting, interesting things that we want to monitor with Docker. Well, I'm speeding through this a lot quicker than I thought. Cool. So we're going to take things that we found have been interesting for us to monitor. We tried to look at how frequently we're seeing paging. That tells us how long it's taking to move things from disk into memory, if that's been slow. Page faults. Really memory usage. A lot of times we find people are thin provisioning. So you kind of want to take a look at how much, you want to take a look at resident set size. Is that causing paging and swapping? And then finally swapping, right? We all know swap is sort of this dreaded thing that is quite miserable on our applications. In fact, in most cases, we like to turn that off in our environments, but it tends to be painful here. Cool. Those are some of the memory metrics we tend to take a look at. On the CPU side, we're looking at things like, again, going back to those work metrics, we're taking a look at things like, resource metrics. We're taking a look at things like how much CPU is being used. Again, that might not be particularly exciting for your users, but as you're trying to figure out how dense to pack your containers on a given host and the amount of resource shares to allocate them with your C groups, you're going to want to look at that and make sure that you're making some good decisions there, both monitoring these things both within the context of individual containers as well as within the host. At the I/O level, even if your individual application isn't necessarily the most I/O intensive app in the world, I/O tends to be sort of a bottleneck in a lot of places, especially when we're loading resources off disk, what have you. So you're going to want to take a look at Is that one of the bottlenecks that you're running into, and just kind of trend that over time. On the network side, especially as we're diving into these massively n-tiered architectures, we're going to start to see, we're going to want to look at things like how difficult is it for app A to get to app B, or between those tiers in your application, from one app to the data tier to the to the app tier to the data tier, what have you. Especially as you're deploying these in units. And so again, we're going to want to look at things like transmit and receive errors on the network, how many packets we're dropping, because they start to show things like congestion, total bytes in and out. A lot of times that's going to give you, you're going to want to look at that and correlate that to how many requests per second is your application serving on the work side. So these are these are a lot of the resource metrics that are going to kind of tie into your into those work metrics we were talking about earlier. Cool. So starting to look at how our current monitoring fits in. I mean, just kind of doing a survey of the audience, how many folks out here, what type of monitoring systems are you using today? I'm guessing if I say Nagios, I'm going to see a bunch of hands raising up. If I hear cacti, I'm probably going to hear a bunch of, everybody seems to be a little ashamed to raise their hands. I don't know why. Nagios is a fantastic tool. I've used it for well over a decade at this point, probably even longer than that. These are all great tools. I mean, that's just what we default to, right? When we come out, when we approach a new problem, while for our personal use, we might dive in and say, let's find the fanciest, schmanciest tool we can, because it's what's exciting and new, and it's what we like to play with. When it comes down to some problem at work, we're going to want to grab the tool we know best. We'll open up our bag of tricks. We're going to pull those tools out. We're going to wonder, how do those fit in? And so we're going to start to survey that ecosystem, and we're going to realize that what we probably used the last decade or two in these infrastructures where we were in data centers, where we measured lifetime of new applications in probably quarters or years, because that's how long it took to get them from our favorite hardware vendor. Again, we're talking about that dynamic infrastructure now. So really, this is kind of what we're looking at as we start to pull out the Nagioses and the cactis and all of these other tools that, again, awesome tools. I love them, but they don't really fit into this world. So why? So we start to look into what we realize these are host-centric. And so this was already problematic when we were talking about VMs, even more problematic when we were talking about auto-scaled workloads in things like EC2 or GCE or Azure. I know we're here in Seattle. Right, those instances are coming and going. You want to be able to track those workloads across those hosts. And when I say track those workloads, I don't just mean like, is this one host up or is it down? We'll get to that in a second. But I mean, you want to be able to look at these metrics, these work metrics, that output that you're looking at. You want to look at that across all of your fleet of applications and be able to make a decision about whether or not you're performing well and where your constraints are. So again, this is just an example of Nagios. I really don't mean to harp on them. I just know that it's everybody in this room has probably used it at one point or another. You know about the pains I speak of. If Ethan Galstad's ever watching this presentation, and I'm sure he's not, I'm sorry. Nagios is awesome. Thank you for all of your hard work. So the second piece is things like, we're looking at static configurations, right? You're spinning these things up and down, and even if you start to take something like Chef or Puppet, again, Chef Summit's in town this week, Ansible, what have you, and every time you spin up a container, whether it be from your orchestrator or from your scheduler or from some command line, and you end up in a situation where one of these blocks gets generated. Again, it's we generated Snowflake #1. We figured out what its IP address is, and we set the pages on it 24/7. The reality is, every time one of those goes away, and they're going away every minute of every hour of every day, most likely, hopefully if we're doing things right, that pager is going to go off. And I think everybody in this room knows what a pager is these days, but I mean, I also mean PagerDuty or VictorOps or SMS or your Slack channel or whatever it might be, right? You want to be able to get work done, get interrupted all the time about something that is normal. That's tough. And then finally, a lot of these things are focused on the resources rather than the work. They're there to tell you, is your CPU utilization high? We're looking at a ganglia graph here again. One of my fallback tools had been for years before I supplanted it with Datadog at Ilan. We're looking at, it's like great that CPU spiked, but if it's a Hadoop cluster and your goal is to get your job done as fast as you possibly can, use 100% that CPU. I don't care, just get the work done, especially if it's something like, something that we've scaled out, we're scaling out as we need it. So cool. So how do we want to sort of approach that? We want to be able to look at our monitoring systems and start to ask it questions rather than having it tell us about these thresholds that we think we've defined in advance. What we want to be able to do is say, across all the Docker containers I've spun up with a given image name in this particular region, in this particular availability zone, let me know anytime they're using more than 1.5 times the load average, right? Like we want to be able to come to our monitoring systems with these types of queries, and the thing about these queries is that they're great. They don't change when you have 100 instances, they don't change when you have 5 instances, they don't change when you have 2,000 instances. They always stay the same because they're simple questions. You say, let me know when that load is higher than 1.5, what the normal average is. Tell me, tell me when less than 3 nodes are up at any given time so that have high availability. But these are things that are not going to change as your scheduler is changing your workloads. And so with that, I would normally dive into a demo, but I don't know that I have time, so I'm going to.
Yeah, I think we should probably move on to the next one. Any questions?
Or demo questions?
How long will the demo take?
It's probably about 10-15 minutes. I don't think we have time to
let's
fit here.
skip that.
I can do that afterwards with folks later.
Okay, so if folks want to stick around after the talk, if they want to see a demo,
Yep.
or if you have time afterwards. Any questions?
No.
Do you have any questions or anything like that? All right, I guess with that, thank you, Ilan. And next we have Ahmet giving us an update on his work with Docker. Now you've been involved with Docker from the Microsoft side since the middle of last year, or maybe sooner, or something like that.
Yeah, something like that.
So yeah, it'd be great to find out what the latest is that's going on. Over on the other side of the pond, over on this side of the pond. He lives over here, works on the east side.
Yeah. Well, good thing I'm not going to talk about anything Windows. We have Taylor here, he's going to do that. All right. So, my name is Ahmet Balkan. I work for Microsoft Azure. This is, I guess, my fourth, maybe third time here at the Docker Seattle Meetup. So today, we're going to talk mostly about the Docker Swarm and service discovery with it. So since now that's being recorded, so I'm going to say different things. So is anybody actually actively using Mesos here? Okay, how about Kubernetes? Mesos or Mesosphere? If you're using Mesosphere, I guess you're using Mesos too, right? So, okay. I guess we have some common idea about Docker Swarm. It's a good thing. It is basically a server that looks like a Docker engine, but it's not a Docker engine. It is stitching your Docker engines together and making them look like one single Docker engine. So when you say, I want to run this container, it will just randomly pick a node and put your container over there. So that's good in a sense, but it's not like rocket science like Kubernetes or Mesos. There is no PhD thesis behind that. It's more like something you probably you could code in 5 days or so, maybe even less. So Docker Swarm is not that bad. I mean, it does certain things. I'm personally using it for my personal purposes. It is serving me fine because I just need to run the containers. I don't need them to be rescheduled when some node goes down, right? So in the cloud, if your node goes down, you're probably not going to lose that data, right? If you say, hey, restart my container whenever this machine reboots, your container is just going to be restarted when that machine gets service healed. You know, the cloud is going to fix things for you. So there is that. And Docker Swarm, I think, is still a good choice for that purpose. If you're not running 10,000 containers, you could definitely use Docker Swarm. So that's my argument. That's the begin with. So let's move on to service discovery. I'm not going to have many slides, by the way. So this is the cluster, right? You have machines with Docker engines in them, and then you have some containers like web, database, and cache tiers, basically. And then the way it usually plays out is the web guys gotta talk to those guys somehow, right? And they are not on the same machine. So you cannot just say localhost 3306 and talk to MySQL, whatever. So those are on different machines, and you gotta find them where they are, or multiple of those. If they're sprayed through the cluster, you gotta find where they are. So this is called service discovery. There are a couple of solutions. Wait, okay. Is anybody actually doing service discovery here at all? Like, has anybody tried that? Cool stuff. Okay. So is anybody using TCP load balancing? Like you put certain containers behind some dynamic HA proxy or Nginx config with interlock, whatever. Some people, awesome. So there's some stuff like etcd console where nodes register themselves to somewhere and then you read things from there. Did you guys, does anyone do that? Awesome. So there's an interesting solution, dynamic reverse proxy that routes the traffic to your container. There is something like that. That's new anyway. So there are overlay networks like Weave, which could easily, with that, they could connect your containers together over some overlay network. They can give you this functionality. Does anybody use anything like that? Weave or Project Zero? Calico? No? Okay. So there's another solution, DNS records. I think, for some reason, I don't know, I like this one. This has been out there for maybe 50 years now. It worked fine until now, maybe it's still gonna work. So the way it works is service A wants to talk to service B, but it doesn't know where it is, so it talks to some DNS server. It says, I want to talk to this service B, where is it? And then gives some IP address back. So this is what runs the internet today, right? So that's pretty much the all of the slides I have. And then, so I'm gonna put in a little advertisement here, and then I'm gonna show you how do we easily create Docker Swarm clusters on Azure. So you can do the same thing on your, obviously your machine with boot to Docker machine, whatever. So we announced that we made creating Docker Swarm clusters on Azure super easy. Do you guys know about, has anybody used the Cloud Foundry templates before? All right, cool. Or CloudFormation stuff? More people, awesome. So we have something called Azure Resource Manager templates. It is basically a JSON file, so this is on GitHub. It says, okay, we don't have a good internet connection. So, it takes a bunch of other parameters, bunch of other things, provisions, IP addresses, network interface cards, virtual machines, stuff, and it's probably like 500 lines. But the good thing is you can click on this button, deploy to Azure, and then you can go to the Azure portal. Let me zoom in. Okay. And then you can ask for admin username, like Azure user, and then you just need to give it a public key. You can just copy your public key from your template. And then once you copy it from your machine, did it copy actually? No. Okay, so DNS name, you can say Seattle is warm. Okay, so, and you can ask 10 nodes, but you can easily say 100 as well. I don't want to leave them running around, so I don't want to end up with a huge build. So you can, I'm just gonna put this in a container called Ahmet Swarm. Waste.js sounds awesome. Legal stuff. Seriously, I hate this part. Doesn't even load. Okay. So yeah, you just hit create and that's it. In probably 5 to 10 minutes, you're gonna have a Docker Swarm cluster. I'm not gonna make you guys wait 5-10 minutes, so I'm clicking on some existing one. So as you can see, this is the Azure portal, by the way. It's nice, right? So, so I have this deployment called the backup one. So I click on resources, and you can see a bunch of cool icons in there, like availability sets, virtual machines, load balancers, network interfaces, stuff. So you don't worry about those; they're just created for you. Your public IP addresses, whatever. So let me show you how we connect to this machine. So if you click on the template output, it's just going to give you a command to do some SSH tunnel. So I already have it here. I'm just gonna, oops. Yeah, so I right now established a tunnel, okay, to the Swarm cluster on the cloud, and then I can just say export Docker host localhost if I run Docker info. See, I'm already in this cluster. I have 10 nodes, 20 CPUs, 25 gigs of RAM, stuff like that. So what I was going to talk about mainly today is a project that I've been working on because I had a lot of free time. It's called Waggle. The name comes from the waggle dance the honeybees are doing when they find food sources and come back to the beehive. So they're wiggling around in certain shape, which is telling the exact coordinates of the food source. Interesting enough.
What's the URL for that?
Say again, please.
What's the URL?
Localhost. It's gonna be out tonight. The reason is it's not open source yet. As promised, I'm gonna open source it right here. How do you open source stuff? Seriously. Oh, this is not it, that's why. Yep, okay. So, Waggle, DNS discovery service for Docker Swarm. Public, yep. So that happened. So you can find some documentation about this in the repository, but I'm gonna make a quick demo after it. So Waggle, in a nutshell, is reading the containers from the Swarm daemon. So it's looking at the Swarm engine and saying, what Docker containers are you running? And based on that answer, it is creating some DNS records and serving as a DNS server. So, and after you install it, you're supposed to forget about it and not talk about it again. So I'm gonna show how to do that. So, as we talked before, I have the, as you remember, I have the Swarm cluster here. So I'm just gonna SSH into the master machine we have. Let's see where that is. Okay, so that's on port 2200. Okay, so I'm in the Swarm master 0 now. Maybe I should move this a bit above. Yep, okay, you guys can see that, right? So there is only a single command that I'm supposed to run. So I'm gonna go through this. Docker run, as you know, restart equals always. So I'm linking the Swarm manager, then run Docker PS. As you can see, there are some containers running here. Where are they? Oh, they're messed up. So one is called DNS, the one I just started. One is called Compose Swarm, and one is Compose Console, because I started these with Compose when I created the code cluster. So I'm linking this container and up here, and I'm calling it Swarm. And then I'm exposing the port 53, which is a standard DNS server port. I'm calling the container DNS, and I'm saying the Ahmet/Waggle container, hey, the Swarm is at Swarm 2375. As simple as that. Now you start to forget about the DNS server. It's over. It's done, literally. So I'm gonna exit this SSH thing and create some containers that we can see that the service discovery is happening. So Docker PS, this is running on the Swarm cluster right now. No containers in the Swarm cluster as we speak. So I'm gonna run some containers, like some web container, like Nginx. So the way I make this container discoverable through the DNS is I go here and I add a label, -l. I call it DNS.service equals blog. Let's say my blog is here, right? So that happens. That landed on Swarm node 1, as you can see here. I'm just gonna run it a couple of more times. And so if I clean this whole mess up and run Docker PS again, as you can see, they're on different nodes, right? Swarm node 3, 7, and 1. So I'm just gonna run some development container, Docker run -i -t, and I'm gonna provide my container a DNS parameter, which is telling, hey, use this name server. So I'm gonna say 10004 because the one I just logged into was called 10004. So you might be wondering, am I just gonna add this -DNS to every single Docker run command? No, you can add this to the Docker engine. If you configure it on the Docker engine, you won't be adding that every single time. So I'm just gonna run my dev container. So assume that right now I'm in a microservice trying to discover this blog guy. So what I do is if I do curl http blog.swarm, Remember, I called it block before. See, it's working. So, and you might be wondering if that is coming from the same source. We can just do something like dash IB, and then you're gonna see that this is coming from this IP address 168.168.0.5, and next time I run it, it's coming from 4, whatever. So the IP address is gonna keep changing. So the way this works is, if I run some dig command, dig, so I'm gonna ask for the DNS-A record, blog.swarm, and as you can see, it is returning me those DNS answers, which is telling me that these are the IP addresses of your container, and then if I run it again, you're gonna see that the results are actually shuffled, because we can do load balancing naturally through DNS, and these DNS records have TTL, time to live, which is 0 seconds in this case, so the TTL records are not cached at all. So there is that, and you can even do, I don't know, more crazy stuff like, so like you can run a Redis container and call it cache, and then you run it, and let's say you're in some microservice again, and then you can totally run Redis commands like, let me bring it up, Redis CLI, and you just say my server is at cache.swarm. So I'm inside Redis server right now, so if I do set AB, get A, so it's giving me B. So this guy right now is probably on some other Docker node. It's essentially in some other machine in the cluster, but it can seamlessly talk to the cache server. Nobody cares where, so that's the goodness in there. So this is heavily inspired by the Mesos DNS project, which is pretty much doing the same thing, except it's on top of Mesos. So it's open source right now. What else? So I got one more cool thing to show. So there's a new concept called Docker volume drivers. They're making it super easy to store your files on the cloud. You can write your own custom drivers to create and mount volumes. So I wrote one for the Azure File Service. Cool thing with Azure File Service is you can pretty much attach the Azure File Service to any Linux machine. So I got a demo here. Obviously, I got a GIF file. You can just say, hey, well, I want to create a Docker volume called foo-share, and then you just say driver is Azure file, and then specify the share name, whatever, and then next time you run a container, and mount this volume to the /data path. So if you go to /data, there's obviously nothing, but whatever you write here, like I created some files, empty files, they are instantly stored on the cloud. So this is using some network file share, and it is super easy to install this on your Linux machine. You just run some command like some process with storage account name and key. That's it. So that's open source as well.
What are the cache properties of that?
Excuse me?
What are the cache properties? Is it?
For the file driver?
Yeah.
It is it is supporting the SMB protocol. It's using the CIFS file driver on Linux. So it's just like any other network file storage. So it is encrypted, works across data centers or other clouds. So there is that as well. If you want to store, I already started using this project simply because I have containers that I don't want to pass configuration every time. So I put my configuration in a volume and I store it on cloud. And every time I want to create that container, I just mount that volume, seamlessly coming from somewhere, and it's working. So I think it's cool. So how many minutes has it been? 95. So any questions?
Can you compare a little bit about the different solutions for the service discovery? Like, for example, the console is actually, it has a DNS.
Sure. Yeah, the thing is, okay, so, console does few things. One is, key value store. One is actually service discovery. So In console, every time I want to configure a service, I'm writing some JSON file, YAML file, or verse their own syntax. See, I don't want to do that. I think the service discovery should be just seamless. You should be able to say, I want my service to be named this, and instantly you're getting that. So there are other solutions like, there's Mesos DNS and Sky DNS, again, doing this thing through the service discovery, through DNS. And they're integrating Sky DNS into Kubernetes right now. And the reason is, the cluster orchestrator should do that for you. Right? You should not worry about this stuff. It is either gonna be so easy to install and forget about like this one, or your orchestrator is just gonna magically support that. But console is not there, right? Console or etcd, you're gonna provide them some file, register your service. Obviously, they're gonna do the health checks for you. They're gonna, take the clusters out of rotation as they go back. But the good thing with DNS records is, so, if I go back here, so the server is actually giving you multiple IP addresses, right? Your host already tries other IP addresses on the client side if they're down or something like that. Alternatively, what I'm suggesting in the documentation is, for instance, you should probably install this DNS server wherever your swarm masters are running. Like I have 3 masters right now in the setup. I should probably install them on every single swarm master, and then I should specify 3 --DNS arguments to the Docker run command so that it's resilient to the failures more. But it's all doing the same thing essentially, but different ways. I mean, some solutions like overlay networks are solving this problem in a different layer. At CD console are pretty much solving it with software. This is pretty much DNS, so they're all doing the same thing at different levels, I think.
Do you persist this information anywhere, or is it just like it's listening to the events API, and then like if you restart it, does it go fetch that information?
Yeah, so let me show you logs for this thing actually. For that, a good thing it's easy to see the logs, but for node-f DNS. So as you can see, this is constantly refreshing the records. I didn't talk about it, but it supports the A records and the SRV records. So the difference between those two is A records are just IP addresses, whatever stuff we use today, and there is something called SRV records, which has been out there for like 5 years, but nobody is using them. But they include the port information as well, which is really important. I just refresh them. This doesn't store anything at all. But it supports a lot of stuff. Like it can work with Docker certificates, whatever. You can configure the refresh intervals. Like if this guy fails to talk to the Docker engine or Swarm, it'll just kill itself after a minute or so. So there's stuff like that, but I don't store anything. So this is super simple. Probably you guys can code in 2 days. I did the same, so it's working. I mean, it has Docker run -- restart always, because it's gonna crash for sure. I wrote it right. Yeah. Any other questions? No? Cool. Thank you.
All right, thank you. Sometimes old school just works, huh?
Oh yeah.
All right. Cool. So next we have Taylor Brown, who's actually more on the kernel side, if I'm not mistaken.
Windows, yeah.
Windows, yep. And giving us an update on where things are at with Docker and Windows.
Wherever Bing takes me every day. I like the Bing change it. Like every day it changes, different background. Sometimes it's cool, sometimes not. So I've been out once or twice before. My name is Taylor Brown. I'm a principal program lead on the Windows team, Windows Virtualization team. And so my team is actually building Windows containers. That's what we're doing. So for the last almost a year now, we've been going to an exec review every month and saying, this is what we're doing. We're building Windows containers that are manageable through an inbox and Docker APIs, as well as Docker Hub integration. And we were saying that before we even really understood exactly what it meant, but that's been our mission for about the last year and a half. What's probably more interesting is actually how we're doing it. So there's kind of 2 pieces to this puzzle. there's the first part of building a container runtime in Windows. Now, I'll spend most of my time talking about that. But then there's the second part of that, which is actually making it all work with Docker. And so the way we're going about that is actually just a ton of work in Docker. So it's been a couple months now that they've been tagging every Windows PR with the label Windows. So you can actually go look at the Docker repo and see every PR that we've done for Windows that's Windows related for the last, I think it's been 4 months now. So I think right now we're up to 241 that are closed, 23 open PRs. In the process of that, the main contributor is now number 14 of Docker as of today. So he's gone from 0 to 14 in like 4 months, because that's all he does is work on Docker now. So the more interesting part, I think, for me and what the broader part of my team is working on is actually the container runtime. So when we think about what a container runtime is, it's really a set of operating system primitives. This is the core parts of the operating system in supporting containers. So there's two big classes of that. There's resource controls, which in Linux we would talk about as like C groups, right? So I can set some quotas on a process tree, these kind of things. Windows, our equivalent would be job objects. We've had those in the operating system for quite a while, and so we're off extending a bunch of those capabilities and changing some of the ways that those work to provide equivalent levels of functionality. The more difficult one is namespaces. So these are like OS objects, mutexes, kernel objects, these kind of things. So in Linux, you think of like PIDs and the net namespaces, mount points, all of these things. In Windows, the biggest one is what we call the OB namespace, or the object namespace. So everything you call down to the kernel and say, give me a mutex, that's created in the object namespace. So we're off virtualizing all of that. We're off virtualizing all of the drivers to make sure they understand there's 2 containers running, and I have to treat these differently now. These are not the same thing. And then I put storage, and storage is kind of an asterisk area. We consider that kind of a part of the namespace. You could have philosophical arguments for all time about whether that's actually a namespace or whether that's something that's different, but we consider that part of the namespace. So when I go off and talk to people about what this actually looks like or how we're actually building it, the easiest way for us to kind of describe it to them is they're familiar with Windows today as a kernel mode and a user mode, where the user mode has a bunch of Windows processes. So if you start up any Windows server, you're going to see some of the same processes. LASSS, that's our security service. You're going to see the service control manager, the thing that actually starts services. Those are common to pretty much any Windows box. And then there's a bunch of application processes, whatever they're running, SQL IIS, ASP.NET, Node, whatever they happen to run. When we actually start a container, all we're really doing is we're booting an entire new user mode, and a new copy of those services, and then we're moving their application into that container runtime. Now what that actually means is that we actually have, in every Windows container, you have a set of processes. There is no container with no process in it. There's no container with one process in it. They have many processes. And that's important because that's the way that Windows works. Windows requires that if you want to write a program that does anything interesting, it builds on LASSS, it builds on the service control manager, it builds on these processes. They're as innate as the kernel is to anything. And so we actually boot a copy of them in each container for the container to use. And so if we had another container, it'd just be a whole other user mode. And that's literally what we're getting is another user mode. We're also building another container runtime, so we're building 2 at the same time, because apparently we like pain. But we're actually building it for some specific reasons, and that's called a Hyper-V container. And what a Hyper-V container does is it actually boots up an optimized virtual machine and an optimized installation of Windows and runs a container inside of it. And we're doing that because it gives us the same isolation properties that we would get out of a VM, so that we can run hostile multi-tenant workloads securely without having any concern about those leaking out and being able to affect each other. So we needed this for a bunch of scenarios in Azure, and we actually found a bunch of customers needed this type of isolation as well. But what's interesting about it is that these runtimes are completely compatible with each other, because we're just running a container inside of it. So if you build a container using the Windows container runtime, it runs in the Hyper-V, and vice versa. It's a runtime option. So in probably about 2 weeks now, we're going to have a demo that's going to go live. We're actually going to show the same exact container. You stop it, you set a new property on it, and you run it, and it shows up as a Hyper-V container. They're completely compatible, and they use the exact same commands. So they're just containers. They show up in Docker as containers. They look like containers. You don't see them in Hyper-V Manager. You don't see them as a VM at all. Because as far as we're concerned, they're not a VM, they're a container. Yeah?
Can you give an example of a workload you would, for example, not feel comfortable running in a non-hybrid?
So one of the big ones for Azure is Azure Automation. So we're taking customer-provided PowerShell scripts, and we're running them on their behalf. Well, if I can craft a PowerShell script that it can attack the kernel in some way, which you could do if you really tried. Now I've taken over that box, the script that's running next to me, that might be your script, gets affected. Or machine learning, where we're taking customer code and running it on their behalf. So having that extra layer of isolation we felt was pretty important. So briefly, I'm going to talk a little bit about how we're actually building images out of this. So we have one special image, being Windows. It's the Container OS image. That's basically a clean copy of Windows for the container. So this is basically a layer 0. You can almost look at it like. So when we actually say Docker run, what we do is we create a scratch space, just like you'd expect, and it's populated with a bunch of basically pointers back to the image that it started from. So in this case, it started from the Container OS image. It's got a bunch of pointers. They aren't real files. They are just pointers back to that file. Now, if I actually do a directory listing inside the container, I see all the folders. Everything's great. If I actually create a folder, it gets created in the scratch space. So just as you would expect. If I create a file, it gets created in the scratch space as well. Now, if I actually commit that, what we actually do is we bring all those over. So we bring those pointers over and say, yep, that layer has a pointer back to the other layers, and we bring those files over. But now if I actually run another container off of it, what we actually do is we have those pointers go back to where the actual files lived. So for the scratch space, for all those OS binaries, they actually point back to the OS layer. So they bypass that other layer. But the files that were created in the new layer are pointed back to layer 1. And what's also interesting is we don't actually create a pointer for this file. We just create the pointer for the directory. Now, as soon as you go into that directory, we automatically, at that point in time, create any pointers to those files or directories that are underneath it. That gives us a performance benefit in the sense that there's a lot of times you never go under a directory. And like some of the Windows directories have hundreds of files in there. We don't have to create any of those pointers. We just do that lazily at the point in time when you actually first reference it.
So can you give a little background on what you're defining as a layer here? These like NTFS, for many years has not had native SID linking capabilities, and hard links were always kind of weird. Yeah. So just if you don't mind expanding on what the definition of a layer is. So
these are layers as Docker would consider them layers. So every do a Docker build, you're going to create a layer. What we're using for these references is what NTFS would call a reference point. And you could look at it as kind of like a hard link. It's basically a pointer back over. And then we've enhanced that capability some to carry things like apples across, where previously didn't have that capability.
So there hasn't been any changes to the file system itself to help support this?
Nope. That was actually a goal, was to try not to change the file system at all for compatibility. We're also building two different container runtimes, or things that run inside the container. You can almost think of this as saying like the difference between from Ubuntu and from Core OS or something. Where the first one is server core. This is more what people are familiar with. So it's got the full Win32 subsystem. It's pretty much a full server version. But then we've got a new runtime that's a new installation option for Windows called NanoServer. And this exists outside of containers as well. NanoServer is a new runtime of Windows Server. It's minimal, remote management, much smaller, much faster, lower patch surface.
How much smaller?
600 meg, boots in like 4 seconds.
So it's 600 meg total nanos, and then server core is?
Server core is like 1.6, 1.8 gig.
Okay.
So considerably big, considerably different. Like this, I'm trying to remember the exact numbers, don't quote me on it, but I think it was 4 reboots would have been required in the last year for security updates with NanoServer versus the 16 that server core would have had total, because it doesn't have the same surface on it. So it's considerably smaller.
So are these going to be the same in that like Hyper-V flavor versus?
You can run them both in either one. Yeah, you will be able to. So what you'll find is the next build that we release as technical preview for, that's what we're working towards right now. We will have runtimes for both in that build. So you'll be able to run containers across both. There's going to be some funkiness for this build as we're still building the capability, but ultimately our goal is you don't have to worry. If you're a developer and you can run your stuff on here today, party on, you should do that. If you still have dependencies on that guy, you should party on. And then as the container host, you can use either one.
What about, just quick, real fast, what about like older versions of Windows? Like say, this is Server 2016, but what if I can have like version flavors?
We're only doing server 2016 and beyond. Because we're out changing the entire kernel right now in Memory Manager. So backporting it literally would be backporting in Server 2016. So all these are fully compatible with each other. So no matter what image you're using, it can run as a Windows Server container, a Hyper-V container. You can use whatever container management you want. So we're doing the work with Docker. We've done work with PowerShell. LXD is doing work to support this now. They've announced a bunch of efforts around that. Mesosphere, more the merrier. Anybody who wants to make a container manager. It's all open source. You can go look at the repo. Some pointers on where you can find more information. These links update automatically as we do new builds. So thank you. Actually, I've got enough time. I think I can pull a quick demo over. I was hoping I would.
So weird to see RDP.
So this is just a VM that is running Docker, but so I can just do Docker run. Just do this. So this is just remotely connecting that VM. So now we're in a Windows container. So I can do directory listing. There's all the Windows files. This is not a nano container. Should learn not to do dir in the root directory when I'm remotely connected. So I can do something from like reg, delete, H key, LM, software. One of these days I'm going to do this on the host. Maybe today. Yeah.
Let's see it with the demo.
Yeah. I've yet to actually blow my machine up. Today could be the day. But
Well, you know,
Are you sure you got that container?
that's what I'm not sure about. One of these days I'm going to blow my entire machine away. It's going to be catastrophic. But I can do full registry access. And now
Delete request is partially.
And you're running this on, you say Hyper-V one or
this is a Windows Server container.
Windows?
Yeah.
So is there anything to indicate that you're actually in a container if you're a developer? Like, let's say somebody handed you something and they were just trying to test you. Like, is there any fingerprint or anything?
Not right now. Nothing. I mean, you could observe some behaviors where you'd say like,
Yeah.
but we'd actually consider those bugs.
Okay.
We are thinking about putting in like a registry key that would say like I'm in a container, but at the same time, from our history, we know that that's bad because then people key off that and say don't run, and we don't want them to easily be able to do that either.
Sure. Yeah.
So it's kind of that catch-22.
Sure. Yeah.
But I can do IP config. I've got a NAT. So we've got NAT networking, transparent networking where we can do DHCP, and then we're working on Bridge and working on some of the new Docker networking stuff as well. So yeah, technical briefing 3 is out there. Give it a play around with it, let us know what your feedback is. We're trying to use forums more heavily for feedback and getting bug requests. And then fairly soon, the next preview is going to be up. It's going to be on more stuff.
How's the integration with Waggle?
Yeah, actually, I want to give a serious answer to this. Turns out Swarm actually works on Windows as well.
Cool.
Just seems seamlessly, so the Waggle works too.
It's actually been fairly interesting. Like We actually got the Docker, we got our Docker management up like 2 months before we got our own inbox stuff working. It was that much faster. The Docker daemon is, I think it's up to 250,000 lines of code, something like that. Our management's like 1.8 million. So it's been kind of fun listening like with the team working on that and realizing like maybe we don't need to do things the same way we've been doing them. Like this is a little more complicated than we needed to make it. So
how this is a technical question, but
Yeah.
how wonky do you feel like the current state is, or for the next technical preview in terms of it being close to production? I mean, just subjectively, what's your take on it?
So technical preview 3 was an alpha. Like no doubt about it. Alpha all the way through and through. Like half the programs didn't work. IES doesn't work yet. We had all sorts of those kind of bugs. We're fixing a bunch of those. They're not done yet. So I would say we're getting close to what I would consider reasonable beta quality. Would you want to run it in production? Probably not. Are people running it in production already? Yes. Do we support them? No. Do we advise that? No. Are we happy to hear that they're being successful? Yeah. Our goal is server 2016 RTM. When server 2016 RTMs, which will be sometime in 2016, we will be at production quality. The interesting thing is like a lot of these app compatibilities, it's one little bug that fixes them all, but it's just finding all of those cases that takes a lot of time. So yeah, thank you guys.
All right, thank you, Taylor. And I guess with that, our last speaker of the night is going to be Christian Pekin. And he's the co-founder and CTO of Sumologic, which does a lot of analytics and monitoring and all kinds of fun stuff. So I guess he's going to talk about Docker support.
Thanks very much. Some heavy-duty stuff here. Wow. It's going to rewrite all the windows. Excellent. No, it's very cool. I think I love it. So I'm going to talk about logging. So this is a little bit of a lighter topic. Let me get cracking here. So this is my obligatory container slide. I just have cats in my containers. So who here is logging? Maybe not right now. I mean, there is a restroom, but it's sort of like professional. You guys use anything like Elk? Yes. Splunk. Sumologic. Perfect. Log entries, by any chance? Nobody? They just got bought today by Rapid7, actually. Amazon announced hosted Elk last week. So there's a good amount of there's a good amount of sort of movement in the space. Actually, really interesting. Turns out, I think if you're building systems today, which are big distributed systems and so forth, anyways, if you don't have logs, it's getting very hard to figure out what's actually going on, right? Okay, so quickly on me, I'm going to make this very quick. I'm one of the founders of Sumologic. Sumologic is a cloud-based log management service. We are in the same space as some of the other companies that I just mentioned. I have, not necessarily by choice, I didn't really grow up to be a logging guy, but somehow my professional career has been in logging, pretty much for the last 15 years. So, about 10 months ago or so, in December 2014, I got a chance to talk to a crowd in New York at the New York Docker Meetup about logging and Docker. And at the time, I had probably spent maybe that would be fun, a month or so, looking into this Docker thing. Specifically from the perspective of, hey, we're a service, so we're obviously a large distributed system. We're always interested in, staying ahead of the curve. Our original architecture is from 2010. It's been around for 5-6 years. We did some stuff our own. We also want to always be basically figuring out what new stuff comes out. So we're looking at Docker from that perspective. Getting maybe combine it with Mesos and get better resource utilization and all these things. But what really kind of pushed me over the edge with this Docker thing was that our customers actually started asking, okay, so now I'm running everything on Docker. And then now I don't know anymore what to do with my logs because somehow they don't come to Sumo. Because Docker adds layers of abstraction and all this type of stuff. And so I started looking into it and just basically learning. And I got a chance to basically present my learnings back then 10 months ago in this presentation that I called 6 million ways to log in Docker. And it was literally almost 6 million different slides. So, just going to run through this very quickly. So we basically ended up presenting a catalog of different ways to log in Docker, from the application, put a file collector, and all these different things. Maybe syslog, maybe in container, maybe out of container. Maybe you want to go to a host syslog, or do syslog to syslog or something. Or just log to standard out, and all of these things. The point there being is, Logspout, actually a really cool tool, kind of superseded a little bit right now. We'll get to that. Maybe you can collect from Docker file systems. I actually tried that. Because one of the questions is, hey, what if my customer has, or what if my user has a container that doesn't really follow the sort of single process kind of thing? What if they still kind of log to files? And I thought that was pretty interesting. And that did not really work out very well because, for some reason, if you use device mapper or something, the files actually end up on the host, right? And the idea would be, well, I'm just gonna tail the whole thing. That worked up to the point where I stopped the container and then tried to start it again. And then it was the log somewhere that I couldn't get rid of, and so that didn't work. Etc. I was even thinking about using the Docker exec API. And I did actually write that over Christmas, to use the Docker exec API to inject the file tailing process into the running container and pipe that back out and collect it that way. Anyways, all this crazy shit. If it's really late at night, you ever want to see, what the state of the art, quote unquote, was like 10 months ago, the link is here. So I'm not going to run all of this again. Today is basically a kind of, hey, it's second season, right? Jon Snow is dead. It's 10 months later. Where are we now? And a bunch of things have changed. Let's just go through the basics real quick. I think everybody has kind of congealed around this idea that, the sort of container-based deployment follows the 12-factor app idea, and if you make it simple and composable, and what 12 factors actually says about logging is that, again, keep it simple, don't involve files, just basically pipe everything back out to standard out, and then hope that your sort of support structure, picks it up. Considering that this 12-factor thing was written, in many ways, or heavily influenced by the Heroku guys, who, probably figured that the only way to deal with this stuff is to simply, attach to their running, processes and whatever container thing that they had, this way, and to make it basically to keep the application that you want to run on a pass as decoupled from the from any assumptions about the infrastructure. So, anyways, it feels to me like people are doing this today. Follow this kind of single process per container model. I think that has kind of permeated through the culture, through the community, and people are doing this today. So that's what we're going to concentrate on. So pre-Docker 1.6, essentially the only thing that you could reasonably do, without going back to some of those slides that I just ran earlier, was to rely on the fact that Docker collects standard out and standard error from each running container and dumps it onto the file system in a sort of a lightweight JSON encapsulation. I hope you can see that. It's under var lib Docker containers. That's anyways the case on my Ubuntu box. I think that's generally where this is. That's where all the container logs go. You see these, long file names. Those are of course the container IDs. You can drill into those. You see there's a whole bunch of different files, including this again repeated ID, blah 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 dash JSON.log. This will be one container. I think this was a hello world container that I was running. And then if you less that thing, that's essentially what you get. So that was the standard output of that container that was running, for some reason encapsulated into JSON, just I guess because we can. But that's what you get, right? And so before Docker 1.6, that's what we had to deal with. So our early hardcore crowd, they would just basically take one of our file collectors. It doesn't matter which tool you use. Ultimately, the agents all basically allow you to recursively, suck in files from your system. We just pointed at var lib Docker containers, and then basically ** here means just collect everything underneath that recursively, right? And turns out it actually works. And then of course there's the docker logs command. Ahmet, actually you said earlier with the follow. Docker logs is actually an API client that talks to the daemon. And what that means is that the Docker daemon actually has an API for getting the logs out. And the log spout by these guys from Kleider Labs, the person's name is Jeff Lindsay, they came up with this idea that, hey, maybe I want to do the next sort of thing, which is I don't want to keep all my logs on a drive. I probably just want to send it to my normal syslog aggregator. So they came up with this tool called logspout, which basically uses the API to get to the container logs and then forward it via syslog. And this is a pretty cool tool because you just have to run one of it per host. It's a container itself. It uses the Docker API to basically follow along with the event stream. That way you can see when new containers come and when containers go. You can kind of keep tabs on all the things that are happening attached to the log streams and just shoot them back out over syslog. All right. So in Docker 1.6, which I think is probably 6 months ago or something like that, maybe even a little bit longer, the Docker guys actually took on this logging thing for a little bit more real, and they invented this idea of log drivers. This kind of predates the whole plugin thing, and maybe one day we'll see this kind of converted to plugins, etc. But again, it's a living, breathing system, and the log drivers have already advanced the state of the art quite a bit. So initially in 1.6, the log drivers that were supported were JSON file. I guess you can figure out what that is. We just looked at that earlier. That's the default, and syslog, which is what Unix people do, right? And then no. And no basically means no logging. So, I don't care about this shit, just turn it off. The way that you would do this is, there's a new command option for the Docker run, and there's a new option for the Docker run command. You say log driver, and then you specify the type. And so in 1.6, this is what you got. Now 1.7 introduced the idea that you can further parameterize what those drivers are supposed to do. So in 1.6, the syslog driver was actually not able to talk to a remote syslog host or even something that was running on localhost or a socket. It was simply using the built-in, syslog, basically, I think it's called devlog or something, a facility that every Linux box has. So now with 1.7, this idea of log options came up, which now makes it so that you can parameterize the drivers. And the syslog driver then was equipped with the ability to say, hey, I want to send to a remote syslog box. And you could do a couple more things like adding a facility and tag, etc. So that's actually a pretty big step up. A couple of the logging services support syslog over the internet, and you could just basically go from container directly there. Well, I guess via the daemon that then forwards it. It was pretty cool. Also, what was added in 1.7 was a driver for journald. So it would just push it down to journald, and journald, if you selected that, and journald, of course, has its own ecosystem of forwarders and so forth. So to each their own, I guess, is what the story there is. In 1.8 and 1.9, more drivers were added, fluentd, something for Graylog. This is a Graylog scale format. And then in 1.9, somebody actually took on AWS logs, so you can use the CloudWatch logs business directly from Docker. It's pretty cool. Well, 1.9 is not released yet, but from all it looks like that AWS thing will actually be in there. Something to point out about JSON file is that up until 1.8, JSON file would just simply dump everything on disk. And so assume you have a host, and it's sitting there, and it's running your millions of containers, right? It's not going to take very long until your disk is out of space, and then you're basically effed. It's not very good. So people came up with kind of, oh, I'm going to put some log rotate thing up and so forth. But 1.8 actually now tackles that by having a couple more options where you can basically tell the JSON file driver, each log file I'm writing or that you're writing should not be larger than X, and don't keep, the basic, rolling setup. Don't keep more than n files around. This is on a per container basis. You still don't really have a way, even with this, you really don't still have a way, if JSON file is being used, to limit the total amount of disk space that the daemon will use. So, this can help, but if you have lots of containers, you might still run out of disk space. There is no real, from all I know anyways, there is no real option or no real solution for that out there yet. Now you could say, hey, but I don't have to run JSON file. I can just go and maybe use syslog or journald or null or whatever. The problem is, unfortunately, this logging API that we talked about earlier, which is the precondition for being able to use the Docker logs UX, which is the command line tool, actually, for historical reasons, relies on JSON file because it provides a very wide interface, including going back in time and so forth, and requiring all of that to be implemented by every single driver, so that the API works actually for every driver was clearly too much, and so now if you are relying on the logs API endpoint or the log CLI, you still have to run JSON file, and you still have to deal with this issue of potentially running out of space. A lot of changes have happened in these consecutive versions of Docker. I'm not aware that there is a solution for this planned right now, but as I said, a lot of things have happened just in the last 6 months, so I'm pretty sure it'll get attacked at some point too. So 1.9 is coming out soon, and it sort of actually tackles yet another problem that people have run into, which is, okay, so now I have all of these containers and all of these daemons, and let's just say I'm using syslog, and I push all of these logs into my aggregator, and then I'm going to say, yay, it's all there. And then you realize, well, but I don't know where it's coming from, right? Because I have all of these, processes in all these containers, and so there's, all of this gets basically, multiplexed over a single connection. Let's say, most people end up using an aggregator of some sort, and so metadata is basically missing. And what 1.9 is introducing is yet another log opt. It's a total rabbit hole thing, but hey, it's cool. Configuration is important, so I'm not trying to make fun of it, but it gets you start with something and it gets consecutively more interesting and ultimately also more complex, right? And now you can basically tell a driver, and this works cross-driver, this is not a driver-specific option, which basically how to compose a particular string that gets plugged into each log message that comes out the other end, as a tag. And this is the Golang template syntax, which I actually don't know a whole lot about, and Ahmet probably knows a lot more about this. But basically, what that says is there is a set of information that you're being given, like for each container, what's the idea, what's the name, image name, etc., and a couple other things. And you can sort of compose this together. And the way that this ultimately works is the image name, maps to this. This is the name of the container that you give when you started. And then ultimately, big surprise, this is the ID. And so this is actually a big deal. We have a lot of customers that use the syslog driver to push into a Sumologic syslog collector, and then the data comes to us, and then it's like, oh shit, there's metadata missing. So we're really happy about this. Okay, that was a quick whirlwind kind of catch up. What are we working on? So one of the things that we have done, of course, is we containerized our collectors. If you want to run a Sumo collector, then that's one way to do it. This is a sample for the syslog case. There's a blog post up that I wrote. Again, it's literally just 2 paragraphs that shows how to do that, and we're often off to the races. Basically, it's really straightforward by combining the syslog log driver with our collector, and all is good. What else we're working on? We've kind of developed this idea that really what you need for this kind of more and more complex environment that we're getting ourselves into here. And, this is definitely something that Ilan alluded to as well. You need some comprehensive monitoring, right? And I think a lot of folks will probably continue to do best of breed, and you put the metrics in Datadog, and you put the APM into New Relic, and you put the logs into Sumo, and all these kinds of things. But I also think that we all owe our customers, somewhat of a more sort of unified, comprehensive solution. And basically, what I've been talking about for a while now is, I want a way to get logs, stats/metrics, Docker events, just for basic bookkeeping, inspect output, and ideally the daemon and host logs, all into one system, so that I can then actually correlate across all of that. And we sort of released an application for that at Docker Company, earlier this year, which, by the way, was like off the hook. It was so busy. I don't know if anybody, was there. I know you were, but it was just crazy the amount of energy there. It's actually really cool. So we have sort of a preview of this up that shows you then, in Sumo what we can do with all this data. And we also, let me see, that was actually my last slide. Yay, done. We're also working on making this a native thing for Sumo, where we will basically be able to, tackle all of these things that I just said, logs and stats and events, etc., and bring them in through one pipe. And this is in testing right now. First version is not released yet, but it's going to be out before the end of the year. And I can give you a quick demo of this. Actually, here we go. So I have the collector running here. It's using the API to get to logs, stats, events, etc., and all the inspect output. And then you can see it here in Sumo. We wrap it all, as far as it's not yet wrapped into JSON. It's a nice thing. Everything gets wrapped into JSON. It's like bacon. Thank you. I'm here all night. And all the data comes into the tool, and then you can basically dissect it from there. And this is working internally, and hopefully we'll have it in your hands at some point later this year. Thanks very much.
All right, so any questions? So we actually have what we have scheduled after this is a panel discussion / Q&A session. I don't know if there are folks who want to stick around for that, or we just call it a night. I'm not sure. Any questions about the talks tonight? Any questions about I don't know, some of the things that you've seen so far, logging, monitoring in general, or what Docker's doing in the Windows world? Please.
Yeah, logging questions. How many of your customers are moving towards structured logging, and what's the impact on containerization?
And could you repeat the question, please?
So the question was, how many of our customers are moving towards structured logging, and what's the impact on containerization? So I know I have the answer for the first question, for the first part of the question, which is some, but so the cool thing about Sumo is that we're getting customers from basically all walks of life, in kind of all levels of sort of seniority of companies, right? And so we have some like good old like on-prem companies just shoving good old logs into the tool, and now they're not structured. Right, we're encountering, some newer companies where they've already started with a clean slate, or where they had some sort of reboot, or a new project that was like, oh, instead of forklifting everything, we are going to leave the old thing there, and now we're going to make a cloud division, right? And yeah, they basically start with JSON, right? And that's why we have all kinds of sort of syntactic sugar for that in our product, etc. So that's definitely coming. I'm not 100% sure how that relates to the second part of the question, so maybe you can elaborate.
I was just curious if you had any thoughts on how that intersected all with containerization.
Well, the JSON that basically is kind of the language of choice now, right? For all, especially if no humans are involved. It feels to me like if humans are involved, you want to do YAML because it's a little bit easier on the eyes. Like Docker composes YAML versus but ultimately the data model is the same, so you can render it out in either way. But JSON is going to it's it basically. I mean, I have. It's been a long time that I've seen anybody actually say XML without like poking himself in the eye. For example, right?
That is so 90s.
So it's J2EE. Yeah.
All right, just one more thing also I wanted to mention. There's lots of pizza line back there, so please grab a box if you want. I'm not carrying 10 pizzas to my car or back upstairs. So, all right, any other questions? Any other comments? Anything else? I have a quick question. What about time synchronization across like a cluster or something like that? What have you typically seen for that? For logging, I assume that's kind of important, right?
It's unbelievable pain in the ass. You know, there's very little that you can do. You know, the basic assumption is that, or sort of, you can try to build a metrics or log management or general monitoring system based on the idea that you just simply timestamp everything when you receive it. And people have tried, but it's just simply semantically wrong, right? So what you deal with, especially when it comes to logs, there's a lot of in Sumo, there's a lot of amount of time that goes into, maintaining the various regexes and try them and, pull them out. We have some inference, all that kind of stuff. Just in order to actually snag the date, right? And then you have messages that have like 3 dates in them, and so then what the fuck, which one are you gonna take, right? So it gets really interesting. And so that's just about getting the date, right? Or timestamp or whatever. And it gets more interesting in light of, I regularly see messages from 2039 and from, the 1970s. It's like a daily thing, right? Always. Even in my own shit. It just happens, right? And so past requiring or basically advising people that they should use NTP and that they should keep an eye out on that for this type of stuff and then fix it. If I had a real solution for that, I'd probably not be here right now. This is a huge problem. So
you also have the problem, right? Just sometimes the logs were logged correctly, and then it took 20 minutes to ingest them or something because that's more than the bottom, network IP of the log.
Because the service is down or it's not working right because these things happen, or because something on the producer side is off, or you decide to batch it to S3 instead of just sending it directly, and now you have polling delays. It's a pain in the ass. And every system, especially that deals with logs, has to deal with sort of trying to make some amount of sense of it. And sometimes sense is, hey, Mr. Customer, your shit is off. You need to look into it. So.
Any other questions? All right, I guess with that, we'll call it a night, and I'll see you all folks next month. Thanks for coming. Thanks for coming.